Hi guys, this is my last minute advice video for physics, so I hope you find it really helpful. Now, the very first thing I want to point out is how important it is that you have your equations correctly memorized, because we know that physics is absolutely chock-a-block, full of calculations. And so obviously if you're not remembering how to arrange your formulae in the correct order, how can you possibly get the marks? Because you're substituting in your numbers incorrectly. So it's so important that you have your equations. And I know lots of people struggle with this, so my favourite way is using formula triangles. And what I would do when the examiner says begin, and it's exactly what I did when I sat my GCSEs, is that I didn't turn directly to question 1. I just found a blank piece of paper in my exam paper, such as this one, and then I just started writing out all my formula triangles off the top of my head. Or I wrote out whole formulae as they appear. I don't really like putting this one into a triangle. Gravitational potential energy is mgh. So how do I remember these? Well, it's really weird stuff like we play tennis for this one. This one I remember from my auntie. The one with density is drunk men vomit, because they're drunk, the D goes at the bottom. Pressure, area and force was FAP. Pressure difference is another annoyingly long equation, so that's pressure difference equals height times density times gravitational force. So I keep going until I have all my formula triangles written down, but hopefully this will give you a good idea of many of the most useful ones. Okay, so I write out all my formula triangles, and then what that means is when I get to a calculation, and I'll show you what I mean later, rather than have to try and work out which of these equations I need out the top of my head, not knowing which order to do it in, then I have them all written here. And remember, in order to use formula triangles correctly, what you do is you cover the letter that you're after. So for example, in this one, I'm after pressure. So I can see therefore that pressure equals force over area. Let's take a different one. How about I'm interested in finding current? Well, current equals power divided by voltage. So let's have a look at an example. So the diagram shows a motor lifting 130 gram mass. The current in the motor is 2.1 amps and the voltage across it is 12 volts. The motor takes 1.5 seconds to lift the mass. Calculate the electrical energy transferred to the motor as it lifts the mass. Give your answer to 2 significant figures. So first of all, what I like to do is label what I have. So this is a mass, and you need to convert all masses, if they're given in grams, to kilograms. So I'm just going to convert that now. This is a current value. Here we have a voltage value, and there's no issues with their units, that's okay. Then 1.5 seconds is obviously a time value. We're being asked to find the energy. So, which of my equations could I use in order to do this? So I'm keeping in mind that I have mass, current, voltage, time, and energy. I scroll back up and I have a look down and see what equations I have. And I can see it's going to be this one, because I'm after energy and I've been given current, I've been given voltage, and I've been given time. So let's write the equation. E equals IVT. We're after E. The current is 2.1. The voltage is 12. The time is 1.5 seconds. And then I get a value which is 37.8. Remember that unit is joules. Now have a look back at the question. It's so important that you check through again, and it says give your answers to 2 significant figures, which is why my final answer here is actually 38 joules. Please don't lose a really easy mark because you haven't obeyed the number of significant figures that they're after. State the equation linking gravitational potential energy, mass, g, and height. Which equation am I after this time? Well, it's this one up here, GPE equals mgh. And it's absolutely fine for you to write this in letters or write it out in full if you want. The motor lifts a 130 gram mass to a height of 63 centimetres. Okay, here's our height, but we need it in meters. So I'm going to convert that directly. We have our mass here, which I've said we already need that in which I've already said that we need that in kilograms. Calculate the gravitational potential energy gained by the 130 gram mass. So write out that equation again, line up your answers nicely to make it easy for the examiner to mark your paper. They've got lots of papers to mark. They want to make sure that they can read yours nice and quickly. So the mass was 130 divided by 1,000. G is gravitational force on Earth, which remember is approximately 10. And height is 63 divided by 100 meters. So just use your calculator. Don't do anything in your head. Just type it in exactly as it looks. And you get a value which is 0.82 to 2 significant figures. The next piece of advice I want to point out is obviously have your stock answers rote learn so that when they come up you can automatically get those marks without too much effort. And one of those particular answers relates to magnetism. Go check out my other video about getting full marks in physics if you want more answers like this. But as is the case in this question, the diagram shows an electric motor and the direction of the current. They explain how the current produces movement of the coil. So it looks like a horrible question, but I think I've said before, this is just one of those answers you have to repeat. And it's in my revision guide if you like these sorts of answers. So the first thing you have to state is the current flowing through the wire creates a temporary magnetic field. This temporary magnetic field interacts with the permanent magnetic field of the bar magnets, producing a force. And then you need to state Fleming's left-hand rule as a final point. And you don't really need to say anything else, but I'll try and make it make a bit more sense. It shows the direction of the coil turning. Other pieces of advice, again, this is a repeat of the other videos, but make sure you know the difference between all your variables. So remember that the independent variable is the one that you change. The dependent variable is the one that you measure, and the control variables are the ones you keep the same. And remember, I said on YouTube, if you Google the variable song, then you'll find it really annoying, but really helpful video on how you remember this. So just taking an example, a student investigates the motion of different falling masses by measuring the time taken for empty cupcake cases to fall from a window. The student drops one case from the window. He repeats the experiment with 2 cases stuck together, then 3, then 4. Name 2 measuring instruments that he would need for this investigation. So we need to work out the mass of these cases, so he needs a measuring balance, and he needs to time how long it takes for them to hit the ground, so he'll need a stopwatch or stop clock. So what are the dependent and independent variables in this investigation? So he said that the dependent variable is the thing that you measure, and it says it up right here, he's measuring the time taken. So make sure you reread the start of the question so you know what's going on. The independent variable, so what is he changing? He's changing the mass of what's falling effectively. So you could say the mass, or you could say the number of cupcake cases. State one factor that the student should keep constant in order to make this investigation valid, a fair test. So effectively they're asking us for control variables. And the most obvious one for me here is make sure that you use identical cupcake cases. The last thing I wanted to talk about is how important it is that you use correct units, because you will be asked to provide appropriate units. So remember that energy or work done both have the unit of joules. Force or weight both have the units of newtons. Try not to get confused here. People tend to think that weight has the unit of kilograms. It doesn't. Mass has the units of kilograms. Speed is meters per second. Acceleration is meters per second squared. That's quite a difficult one. Distance tends to be in meters, so make sure, like I always say, that you've converted all your units to the standard SI unit. Voltage or potential difference is given in volts. Current is given in amps. Charge is given in coulombs. Resistance is given in ohms. So do spend a bit of time making sure you've learnt all of these. Pressure tends to be in pascals. So if they give you kPa, I mean, obviously check the unit of the question they're asking. It may even be in kPa, but ordinarily you'd have to times that by 1,000. Frequency should be provided in hertz, and sometimes they give you this, which always looks gross, like megahertz. Now remember, to convert that into hertz, you want to times by 1,000,000, so please don't slip up there. But yeah, good luck guys. Try and remember all your formulae, try and do the sheet thing. I know it seems long, but honestly you can probably scribble them out in less than a minute.